Thanks for having me, everybody. Um, yeah, as mentioned, my name's Nick. I'm with a company called Ecopilot AI. We've been in business for about 10 years in North America now, but just kind of cutting our teeth in Alberta with a few commercial demonstration projects. But Saria has helped support us get into a new building typology here. I'll get into that here in a few minutes, but really excited to get started here. We're a little bit, I think, behind some of the other projects. We're still in the installation process, but we'll be going live here within the next couple months. So yeah, what Ecopilot is we're a software solution. We're looking to enhance the existing building automation system. And for those who don't know, the building automation system, or BAS, as I'll probably call it the rest of the presentation, it looks after a number of things in your building. It could be lighting, it could be security. Our focus is on the HVAC system of a building. So trying to add another layer of intelligence to make it smarter, and keep people comfortable or even improve comfort where possible. And we do that by bringing in extra data points to make smarter decisions. So for this application, what we're doing is trying to enhance a senior care facility in Calgary. As you can imagine, senior care, you're going to have a high energy demand. People need a little bit more thermal comfort, of course. So comfort comes number one, and then we're trying to get these energy savings second. Um, so the way we do that is we actually disperse temperature sensors throughout the building because the whole idea is we want to be cutting back on that HVAC energy, so the electricity and the natural gas consumption in a building while maintaining that comfort. So by having those sensors in place, we can dial back that consumption while making sure we're still having a very keen eye on the comfort of the residents to make sure their care is still number one priority. Next slide, please. So to get a little bit more fine-tuned with what we're focusing on here is we're trying to establish something called a balance point temperature. I'm gonna talk a little bit more about that here in a minute, but essentially what it is many buildings will overheat and overcool their problems away. You add more energy, you don't have as many complaints. So what we're trying to do is find that the actual need of the building at any given time and planning for proactively in the future, finding that balance point. So in order to achieve that, we integrate with the BAS. It goes on site. We have a little black box, plugs into the BAS. That's where all the calculations happen. And what we do is we actually just send temperature set point offsets to that BAS. So we're not taking over all those other artillery systems. All we're doing is sending a new set point. I'll show you what that looks like here in a graphic in a minute. But instead of, say, maybe 60-degree boiler water going into the loop, we've done our analysis every 2 minutes, and we say instead of that 60, we actually only need 55. So we bump that down a little bit. We're still keeping an eye on that comfort in the building and making sure people are comfortable while saving energy. Because as you can imagine, you don't raise that temperature up as high, you're going to save more energy on that boiler loop because you're not using as much natural gas to get to that set point. So the way we do that is we prepare the building ahead of time. So we watch the 5-day weather forecast. We have a sensor on site to actually read the outside air temperature in real time as well. And we collect those data points from those temperature sensors. And every 2 minutes, the algorithm is recalculating, making sure we're on the right path to keeping everybody comfortable in the building. The next one, please. So yeah, the difference between the classic way of keeping the comfort in a building is called outside air reset. There's other ones too, like trim and respond and whatnot. Typically you'll see outside air reset, and what that looks like is um, there's once the building's commissioned, they'll figure out at a given outside air temperature how much heat they want to put in that central heating loop to keep people comfortable in the building. As you can imagine, as the temperature changes throughout the day, it's gonna bring that up and down. That's a reactive measure. What we want to do is be proactive, planning for the future, not just for the needs of the building right now, but also what's coming down the line. So what our algorithm takes into account is components such as I mentioned the weather, the internal comfort of the building, but additionally the thermal mass of a building. So we plug in an assumption at the start of a project where we come up with a calculation of how much building materials thermal mass is going to affect the amount of heat energy coming in and out of the building and factoring that into our decision making. So if you have a building that's got a high thermal mass, meaning concrete, brick, stone, it's going to be able to, every building already does this naturally. We're just taking advantage of it. So if you have a thermally heavy building with those heavy building materials, it's going to change temperature slower than say if you have a stick frame building, just steel and glass. Those kind of materials don't absorb that heat and release it slowly. So we want to A, get into the most thermally heavy buildings we can because we know we can leverage that to save energy, but also cater our algorithm to what's actually in place there. So that's what goes into us trying to figure out that balance point temperature for each project and making sure that we're planning, balancing both the future and the present needs for a building's thermal mass. Next slide, please. So to visualize that, this is a quick look at our interface that we put into a BAS system. And as you can see, the yellow line there is outside air temperature. It gets warmer during the day and cooler at night and whatnot. There's many buildings that will just have this is a cooling situation. I put this in here because it's summertime. I keep talking about heating, but we do heating and cooling. We're in Canada. We do a lot of heating, right? So if I'm talking about heating, all the same principles apply to cooling. So this green line at the bottom here, as you can see, this is a building actually in Calgary. I pulled up a few weeks ago. And you can see they cool their chilled water in the building to a static point at all times. So they would be cooling it almost down to 0 degrees C. Very cold. And as from us putting our system in, putting our sensors in, doing our real-time calculations, you can see that we're actually able to send that offset to just over 5 degrees, sometimes almost up to 10. So you're not using as much electricity in this scenario to keep that water cold. So you're saving energy. This area here, this gap, this is where you're saving energy in between those purple and green lines there. Next slide, please. So more specifically about the Sky Point location in Calgary, about 2,700 meters squared, 7 stories high. In some places, the floors are tapered in different areas. Relatively newer building, just 9 years old. Um, and we've got about 3 boilers. We're going to be optimizing the main chiller system and then 4 ventilation units, so like air handling units. And what we're going to be doing with these systems is optimizing their start and stop times, depending on all those variables I've been talking about, and also setting those offsets. Next slide, please. We're expecting to save around $22,000 in utilities a year, which works out to about 10% of the current HVAC energy baseline. One thing I forgot to put into this slideshow is actually we're expecting to reduce emissions from the HVAC system by about 156 tons annually, if everything goes to plan. Um, you'll also see there's different columns here. We've got the anticipated energy savings, and then there's also a guaranteed. The way that works is before going into a building, there's always unknowns for a solution like this. So we're saying with the guarantee scenario that we've got the utmost confidence that this would be the worst case scenario if there's surprises and whatnot that we're not expecting. We know that the building is currently being overheated by probably 7% more energy than it needs to be. So we know we can reduce that by no problems asked kind of thing. So um, that's that for that slide. And I think I got one more. Perfect. So if this project's successful, what does that look like? I mentioned the 156 GHG reduction annually. Any sustainability project, you have to marry both the financial and the environmental impacts. So we're expecting to see a good payback here with SRIA funding. Aged care is going to have a very good simple payback and ROI on this project. We're really hoping to demystify this technology. It's amazing. The same outside air reset strategy has been used for a very long time. Some people are nervous about trying new things. People want to see projects in their own backyard with their same building typology and same climate. So it's really important for us to have demonstration projects like this that are local, example with reputable companies like Aged Care that can help us demystify the technology. There's always the goal of improving the tenant comfort as well by being more proactive. We're hoping that there's going to be less swings up and down to make sure that everybody, all the residences in this building are getting the most comfort that they can ask for. Um, Building trust and relationship with the IT department. That's usually our biggest hurdle about getting into a building, is that the IT department might be nervous about security risks and whatnot, which is fair. So we just want to be able to demonstrate and help again demystify our technology with the IT departments. Um, and then also just proving that this is a tool that's going to make the operators' lives easier by one less thing that they have to worry about. I had an email the other day from somebody that was saying, "Oh, it's almost getting cold. We need you to raise your boiler temperature set point because the cold weather's coming in." And so it was a good opportunity to re-educate and say, you know what, that's actually what the technology is doing every 2 minutes. There's no need for these manual changes anymore. Now you can turn your focus on more high value tasks throughout the building and add more value. So um, AI is not going to take this kind of AI technology is not going to take anybody's job or anything. It's just going to make your life easier and take care of something that really a human can't calculate on the fly on a regular basis. So it just makes everybody's lives easier. And that's it. Thanks, guys.